Okay, so I want to start with some examples with hypothesis testing. And the first examples that we're going to do are just kind of getting used to talking about critical values, p-values, and so on. And so let's suppose that we have some hypothesis test. It's going to be a left-tailed test. And what we're going to do is we compute that our standardized value z naught is negative 1.19. So what we want to do is we want to determine, so this should say z naught, just to be consistent with my notation from above. And we want to determine the p-value. And so what this means, remember, is if we think about a standard distribution, this has all been standardized, so everything's symmetric about the mean 0. Okay. So we want to think about if we have negative 1.19, what is this area going to be? What's the probability that our data is at least that extreme? And this is a left-tailed test, so at least that extreme means just negative 1.19 into the left. And so if we want to compute what this area is, that's what we're going to call our p-value. Okay, so our p-value is that area. And this is nothing more than the cumulative probability under the standard normal, just under the standard normal distribution up to negative 1.19. And so it turns out that when you compute this, what you're going to end up with is 0.1170. Okay, so that's going to be the p-value for this standardized value of negative 1.19. Now, at the 5% significance level, do the data provide enough evidence to reject the null hypothesis? And what we want to decide is the p-value less than or equal to alpha or greater than alpha? And so in general, if p is less than or equal to alpha, then we're going to reject the null hypothesis. If p is greater than alpha, then we do not reject. We fail to reject the null hypothesis. In our case, our p-value is 0.117, and our alpha, our significance, was 0.05. So since p was bigger than alpha, we fail to reject. Okay, so that's all that happens there is we're going to fail to reject the null hypothesis. All right. Number two, we're going to do the same thing except it's going to be for a two-tailed test. In here, we want to know, let's suppose that we have a standardized value, z naught, of 2.85. We want to know what's the p-value. Well, in our case, since this is a two-tailed test, we have two things to consider. We have to look at 2.85 here. So we have to figure out what's the probability that our data was at least as extreme as this, 2.85, but that can go in either direction, negative 2.85. So at least as extreme when you're talking about a two-sided test means greater than or equal to 2.85 or less than or equal to 2.85, with 2.85 being, in this example, the standardized value that we receive. So that's the p-value is going to be whatever these areas are added up. And there's two different ways that we can do this. So one way, if you wanted to do this just without thinking at all about any properties of this curve, could be p norm of negative 2.85, and that'll be this area, plus this area. Okay, so plus 1 minus p norm of 2.85, right? So that would be p norm of 2.85 would be this entire probability all the way down, and then 1 minus that would give you this area. Okay, so that's one way to do it. Another way to do it is just to notice that by symmetry, this area and this area have to be equal because everything about the normal distribution is symmetric. So you could also just do 2 times p norm of negative 2.85, which I think is a little bit nicer, a little bit more elegant. And it turns out that when we do this, when we compute this, we're going to end up with 0.0044. Okay, so that's our p-value. Now, the question says at the 1% significance level, do the data provide enough evidence to reject the null hypothesis? And again, we just have to go back and compare our p-value to the significance level alpha. And so our significance level was 1%, so 0.01. Our p-value was 0.0044. And since p is less than or equal to alpha, we do reject the null hypothesis. Okay, so we have enough evidence to reject the null hypothesis, and that's really it. Okay, so in our case, we would reject the null hypothesis if the data gave this standardized value for the significance. Now let's do some with the t distribution. This is going to be exactly the same thing here, except, well, I shouldn't say exactly the same thing because it's not, but it's basically the same thing, just with the t distribution rather than the normal distribution. So let's say that we have a two-tailed, in this case, a two-tailed test with the critical value, the standardized or the studentized value t naught equals negative 1.71, and we want to determine the p-value. So what we're going to do, we're going to take our t distribution. This is not the normal distribution, but the t distribution, they look basically the same, at least when the number of data points is large. Here we have 25 data points, so we have 24 degrees of freedom. And we're going to think about 1.71 and negative 1.71. And then we're going to add up these areas. And it turns out when we add up those areas, well, there's going to be two different ways that we can do it. We can again use the symmetry like we did in number 2. And so this will be 2 times, oops, this will be 2 times, and then we have to think about how we're going to do this. So this will be 2 times, here we have to think about the cumulative probability up to a certain place in the t distribution. So it's going to be pt instead of p norm, negative 1.71, okay, with a standard deviation of 24. With a standard deviation, with, with 24 degrees of freedom. And so that's going to end up being 0.1002. Okay. And so we want to know at the 5% significance level, the data provide enough evidence to reject the null hypothesis or not. In this case, we do not reject because our p-value is bigger than alpha, right? P was 0.1, our alpha was 0.05. So in this case, we do not reject the null hypothesis. Okay, so that's really all that there is to say there.